everyone. So by now, I think we have heard a very good sales pitch. I think we should all go and buy Salesforce right away. But one thing I wanted to share with you is that we are here in this room. The room is pretty packed because we all believe that machine learning and AI can do something good for us. I mean, it can predict what action will a user take. It can predict what product will your customer buy. It can predict if you are a bank, like, is this a fraud? So we all know that. Like, this is what AI and machine learning is supposed to do. But what if we had a machine learning system that was very accurate and it told you that 20% of your customers will churn next month for your company? I'm sure that's a little scary statement, and your next question is going to be, so what do I do to prevent the customers from churning, right? So as entrepreneurs, as technologists, we are here not just to predict the future, we are here to change the future. And that's the message I want to share with you in terms of what machine learning capabilities you need to build in your company, in your team, in your product area, so that you are empowered to not just do prediction, but to also think about what you need to do to change the future. The way I think about it is in these three steps. Data is like the foundation. That's the base capability you need when you're building a machine learning system to really understand what's happening today. That's like your core. Based on data, you predict something like a churn or a customer buying a product or something happening. But then you need experimentation to test interventions or actions so that you can change something about the future. And that's the premise that I'm going to use for the conversation for the next 10 minutes or so. So let's talk about the data first. I mean, it involves kind of building the real foundation. And first things first, it's about building a data-driven culture. I can offer you a simple test. If you're sitting in a meeting and someone is presenting a lot of data, a lot of charts and numbers, and trying to make a point, you kind of ask them that, did you make that chart after you formed your opinion or before you formed your opinion? And you will know whether it is data-driven decision-making or it is decision-driven data-making, right? I mean, they sound awfully similar, but they are very different things. And if you are embarking on a journey of machine learning in your product, in your company, you have to start here, right? That's how you will kind of really build a foundation for your product, for your company. The second thing to think about data is what powers all machine learning systems. And you will be surprised that 80% of the time will often go into organizing, processing, collecting, storing, and keeping the data so that you have a good machine learning system in place. If the data is not good, you can't have a good machine learning system. So that's the second capability you need to invest in and be prepared for it. The third thing to think about is data is your asset, but it can quickly become a liability as well. If you are not protecting the data, if you're not using it properly, forget about machine learning. Even that point, it'll sink your ship. At Google, we take data security so seriously, we have 700 engineers working on security alone. So if you are working on building a machine learning product, make sure you're collecting data, investing the time in that, make sure you're investing the time in securing and protecting that data as well, even before you get to machine learning, right? Okay, so next, let's talk about the real meat of it, right? The machine learning. So with machine learning, there's this notion, and Phil tried to kind of make it like simple for us to say that people think of it as a black box. It's very complicated, but it shouldn't be. It should not be a black box. In fact, machine learning is getting democratized. It's getting more accessible. Now, as you are building products, you don't have to build a whole system from scratch. I mean, you can start with some machine learning as a service. Phil talked about that. You can use a lot of APIs that are already there for you. Vision, speech, image recognition, natural language processing, and many others. But the most important and interesting thing is that machine learning is now also getting more open sourced. There are very nice, sophisticated libraries which you can use to build your machine learning systems, like TensorFlow. And use those so that you understand what's really going on. And don't treat it like a black box. So that's my one message for you. Machine learning should not be a black box. I mean, the idea is pretty simple. You have lots of data that goes into a model. That model is a black box. Out comes a recommendation, and then it feeds into some workflow. So the machine learning system says that this is a case of a fraud, or this patient has this rare disease, and then you expect the doctor to then act and go into a workflow. Now you want the doctor to really understand why did it make that recommendation, right? So explain to them kind of what data went into it, how did the algorithm work, how did this recommendation come about, so that it builds trust in your system. So that's definitely very, very important as you embark on this journey. The third piece about machine learning is that it is tunable, it's adjustable. So let's take an example here. So everybody can see the picture here. Let's say these 100 objects in this picture represent 100 accounts. And the triangles are the accounts that are fraud. So these are the fraud cases you're trying to identify fraud. And the circles are your good accounts, the good customers. Now you build a system, a machine learning algorithm to identify the 10 triangles, but it's not perfect. You can't just identify everything perfectly. You catch some of the triangles, but you also catch some red circles in that process. And these red circles are false positives, right? So these are not fraud, but you think it is fraud. And the red triangles is a false negative. You wanted to catch it, but you missed it. So now comes the job of the machine learning group to say, okay, if we want to catch the red triangles, and let's say the red triangles are very important to us, they are worth $500, and the red circles is if you think something is a fraud, you send a human team to investigate, and that costs you $100. So now you can say, I'll tune my machine learning algorithm. I'll stretch my prediction or expand my prediction so that I can catch the red triangles, right? But in that process, you have to make sure that for every red triangle, you're not catching 5 red circles. Because that's not a machine learning system you want. So think about like what product are you building? How is it fitting into what you're really trying to do? And make those intelligent trade-offs. So move away from this idea that machine learning is sophisticated, complicated black box. I mean, it's a power that you have, and then you can play with it. Let's talk about what happens next. Right? So if I go back to the example I shared before, if I said 20% of your customers are expected to churn next month. Now, you're not happy with that. You want to do something about it. So what do you want to do? You want to do an experiment. You want to see that if I give a discount to some customers, if I send my sales team to go talk to some customers, or if I send them a bouquet of roses, will that action actually lead to the customers staying on our platform, the users staying on our product? And that requires discipline. It requires discipline around experimentation. A lot of groups don't have that discipline. The idea is, oh, let's do something and we'll see what happens. That's not an experiment. An experiment needs to have a proper control group. So when you're building your machine learning system or a process, think about experimentation up front. It should not be an afterthought. It should be built into your system, built into your workflow, so that you are testing things as part of your machine learning system. And not only testing things, you are taking that and making it back into a feedback loop. So if you said, okay, sending a roses, a bouquet of red roses to the customer actually really helps in reducing customer churn, then you want to include that signal back. If you say that, okay, we predict that this customer will buy this product with 60% probability, but if we give them free shipping, then the probability jumps to 80%. That's what you want to do, right? You just don't want to predict the 60%. You want to change something about the future. So that's where the real experimentation comes in, and that discipline comes in to build the product that you want to build, to change the behavior that you want to change. The last thing to think about machine learning, and this is kind of my most important message to you, as you are embarking on your journey of machine learning, pretty much everybody else in this room and all your competitors are also embarking on the same journey. So you will build a machine learning system, you will collect some data, you will tune your algorithm, you will set up experiments. The guy sitting next to you will do the same thing. What will make yours better? I mean, a few colleagues of mine left Google some time ago to start a company on an idea that banks lend money based on credit score. And their idea was that instead of using credit score, we will use GRE score, SAT score, GMAT score, LSAT score, and that is going to be a better predictor for whether someone will pay back their loan or not, right? Cool idea. But do you think they're alone? No, other people will get the same idea. They will also try to build a similar system. The question is, are they collecting better data? I mean, it's one thing to say we'll take GRE score, but how do you make sure that it is the correct GRE score? It's not fake. What is your checking process in the system? How do you make sure you build and tune your algorithm correctly? And then what experiments will you run to really make sure that your system is outperforming the system of the guy sitting next to you who's also doing machine learning. So once you get into machine learning, there's no turning back. This is a lifelong kind of play that you will be doing forever. So with that, I'll kind of summarize that as you embark on this journey, invest in creating the right data platform, the right data infrastructure, and the right culture in your team, in your product area. Invest in understanding machine learning. Don't treat it like a black box. Invest the time to understand it so that you can build and tune and make trade-offs, and then finally set up the experimentation infrastructure up front so that you have a good system in place that has a feedback loop, it gets better over time, and then hopefully you can stay ahead of your competition. With that, thank you.